Let's look at mixed powers of secant and tangent to see if we can make any useful substitutions. Remember, if we let u equal tangent of x, the derivative is secant squared of x dx, and if we let u equal secant of x, the derivative of u is going to be secant of x times tangent of x dx. Well, if we're looking at the integral of secant to the m times tangent to the n, then if m is even and m is greater than 0, we can make the substitution u equals tangent of x and use one of the factors of type secant squared of x to replace du. And then the other secant squared of x's can be converted into functions of tangent of x using the formula secant squared of x is 1 plus tangent squared of x. This is going to work even if the power of tangent is 0, as long as m is greater than or equal to 4. And of course we can deal with the integral of secant squared directly. Let's look at the integral of secant to the 4x times tangent of x dx. So this fits the bill. The power of secant is even, and we're going to try the substitution u equals tangent of x. And we're going to split that secant to the 4 into two copies of secant squared. It's equal to secant squared times secant squared, and the tangent of x can be converted to u directly. So letting u equal tangent of x, we have du is secant squared x dx, and secant squared of x can be converted to a function of u as 1 plus tangent squared of u. And now, replacing everything in terms of u, we have the integral of secant to the 4x times tangent of x dx is the integral of 1 plus u squared times u du. One of those secant squareds gets absorbed into the du. And this, of course, can be dealt with using the power rule. It's the integral of u plus u cubed du, and of course that's u squared over 2 plus u to the 4 over 4 plus constant, and then replacing the u by tangent of x, we get our final answer, the integral of secant to the 4x times tangent of x dx is equal to tangent squared over 2, tangent squared of x over 2 plus tangent to the 4x over 4 plus a constant. Now, on the other hand, if the power of tangent is odd and the power of the secant is greater than or equal to 1, doesn't matter whether it's even or odd as long as there's at least one secant there, then we can use the substitution u equals secant of x, and then of course du will be secant of x tangent of x dx. We'll be left with an even power of tangent, and we can convert tan squared of x to secant squared of x minus 1. This is going to work as long as the power of the secant is greater than or equal to 1. Let's look at the integral of secant cubed of x by tangent of x dx. Here I claim that the substitution u equals secant of x is going to work, so I'm going to have to split away one of those secants for du, which is going to be secant of x times tangent of x dx. Letting u equal secant of x, I'm going to replace secant of x times tangent of x dx by du, and of course I'm going to replace secant squared by u squared. So making the conversion, I get that my integral is the integral of u squared du, which is very simple. It's just u cubed over 3 plus a constant. And now remember, u was secant of x, so that's secant cubed of x over 3 plus a constant, and I'm done. There's some extra examples in your notes, which you should also look over. Okay, so we've seen that the integral of secant to the mx times tangent to the nx dx, if m is odd and n is even, then we can't make any of the previous substitutions. But we can reduce to powers of secant using our identity secant squared is equal to 1 plus tangent squared. Our tangent squared equals secant squared minus 1, and this might help. So let's look at the integral of secant x times tangent squared x dx. Now in this case, neither of our previous substitutions will work because the power of secant is odd and the power of tangent is even. Well, we can write this as secant x times secant squared x minus 1 dx, and that's secant cubed x minus secant of x dx. And then you can see how to calculate these integrals in the powers of secant section below. Also, you'll see the integral of secant cubed of x times tangent squared of x in our extra examples.